is a little bit more complicated. Okay. So here are the rules for matrix multiplication. We are going to multiply A times B and A is this and B is this. Now, guys, could these be added? If this was A plus B, no, they cannot be added because the rule for addition is they have to have the same dimension. Did I leave a notebook out back there?
Yeah. No, I just put it back in.
Okay, thank you. The rule for multiplication is this. Figure out the dimensions of your two matrices. What are the dimensions of this guy?
2 by 2.
2 by 2. 2 rows, 2 columns. How about this guy?
2 by 3.
2 by 3. When we multiply, these numbers must match. That's the only rule. We don't care about anything else. Those two must match. The answer, the product then, will be these. So the answer to this is going to be another 2 by 3 matrix. Okay? Now you do not have to do this, but I want you to see this is going to be a 2 by 3 matrix. So I have to actually come up with 6 numbers now. Okay? Now it's real easy. Takes a minute to do, but it's really easy. When we multiply, we take the first row times the first column to get this number right here. That number is in the first row, first column. So I'm going to take my 1 and my -2, and I'm going to multiply it by my 1 and my 4. So I take 1 times 1, first times first, second times second, and I add them up. Does that sound familiar to anybody? That's a dot product. Yeah. If you think of this as a vector and this as a vector, you're finding the dot product. That's all you're doing. So 1 minus a -7 for that one. And then guess what? First row, second column. So still 1 and -2, but now -1 and 0. So what's first row, second column? -1, yep. Go ahead, fill in the rest, see if you can get the rest. You multiply the row times the column. Always rows times columns. Always, always, always. Remember, it's like a dot product. So first times first, second times second, add them up. How do those numbers look? Is that what you got? Looks right. This says, okay, good deal. Sammy?
If B was 3 by 2, would you still be able to multiply?
No, because these numbers have to match.
Well, if you move B over in front of A, then I don't know.
Okay, but that wouldn't be A times B. That would
Okay,
be
so the
B
order
times
does
A.
matter.
Order does matter.
Okay.
So yes, Sammy, you hit on something. Matrix multiplication is not commutative because we can multiply these, but if we turn them around, we couldn't even multiply. Right? Oh, actually, yeah, we couldn't even multiply if we turn them around. So it's not commutative. Order matters. All right, B times C. What are the dimensions of B? 2 by 3. What are the dimensions of C? 3 by 3? Can these be multiplied?
Yeah.
Yep, and the answer will be another 2 by 3. So, it's so easy to make careless mistakes, so be careful. But remember, it's row times column. So it's 1, negative 1, 1, that's my row, times 1, negative 2, 0, that's my column. And I'm gonna add those up. 3.
How do you know how many boxes? Is it the most number that you go with?
It's gonna be a 2 by 3.
Right, for the one before, is it all?
It's gonna be a
Oh, 'cause it's the last
2
number.
by 3, yeah. All right, and then just keep going, you can do this.
Your idols in it, and your idol skeleton. And then I was the queen.
All right, how goes, Lord? Are you done already?
I picked this one of you. We're not presenting them. We're presenting them as you right? Like,
Don't let me make a mistake, it's definitely possible.
Oh, yeah.
Okay, folks? All right. All right, next, A squared. What do you think A squared means? No, I wish it were that easy. No, what do you think A squared, what does A squared always do? Multiply by itself, that's right. So, are you going to be able to square every matrix in the whole wide world? It has to be squared. Yeah, it has to be squared, or you're not going to be able to do it. We can do this one. We're just going to multiply A times A. So it's a 2 by 2 and a 2 by 2, so my answer is going to be another 2 by 2. Okay, I did that in my head, so it's probably all wrong. squared look to you?
I did this one, this, this one.
Does this look okay to everybody? Now, I said I can't even do that last problem there, I said I can't even do it. Because the dimensions of C are 3 by 3, and the dimensions of B are 2 by 3, and that can't be multiplied because those don't match. Not even possible. All right, now we're gonna prove that these guys are inverses. I think we talked about this the other day, but maybe we didn't. What does it mean? What does it mean when I say that 2/3 and 3/2 are multiplicative inverses? What does that mean? When you multiply them, they cancel out, or they become one, which is known as the identity. If these are inverses, when I multiply them together, I will get the matrix identity. All right, I think we talked about that, but let's look at it and see what happens. Let's multiply these two together. It's definitely doable, right? Definitely doable. So go ahead and multiply and tell me what you come up with. What'd you get right here in the 1-1 spot? 1. What'd you get right next to it? 0. That's called the identity. I know we talked about this because we said this is I and this is J. Yeah. If things are inverses, matrices are inverses, when you multiply them together, you're going to get the identity. Okay? All right. Well, in a little bit, we're gonna find our own inverse, but before we can do that, we have to learn how to find what's called a determinant. So when I look at problem 4, notice that it's not the matrix brackets, it's like vertical lines, like absolute value, and that is the matrix notation for determinant. Do not get determinant mixed up with discriminant. What's a discriminant? What's under the radical in the quadratic formula, b squared minus 4ac. A determinant is a single number. Okay? And how we find it, real simple. We multiply these two together. Look where I'm pointing. We multiply those two together. We multiply these two together. And then we subtract. So it's this product minus this product. So the value of this determinant is 1 plus 18, 19. You need the determinant to find an inverse. So that's why and to do other things. But that's why we're figuring that out right now. All right, how about the next one? 1308. What's that determinant? 8. It's 8 minus 0. So that would be 8. How about C? No can do, my friends. The only matrices that have determinants are squares. If it's not square, it's not going to have a determinant, it's not going to have an inverse, it's not going to have a trace. this one. Ooh, D. Now, there are different ways to do this. Most people find it easiest to do a 3 by 3. Most people, not everyone. So I'm going to show you the other method here on our next couple problems here. But to do a 3 by 3, one really easy option is to cut and paste the first 2 columns right here, right next to the determinant. So just recopy 130, negative 111. Now, don't mix them up, don't change the signs, literally copy and paste. Now, multiply these 3 numbers together. So just like you multiplied these, we're going to multiply these 3 numbers together and get negative 4. Then we're going to multiply these 3 together and get 0. And then we're going to multiply these 3 together and get 0 again. And then our total goes up. And that's negative 4. So we'll multiply, 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 add up. Then I'm going to turn around and do the same thing over here. So multiply, 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 and add them up. Now, yes. Yes. Remember, in the 2 by 2s, didn't we multiply, multiply, and subtract? This is the same thing, it's just more of it. So we multiplied all these and got negative 4. We multiplied all these and got 14. So the answer to the problem is negative 18. You subtract. In a determinant, it's this minus this. All right, anybody have a question about one of my numbers up here? Everybody following along? All right, try the next one on your own. Same exact thing.
So the first one is 75. Let's go back to the Oh. I always only have. It's like habit.
George, what do you think? Did you get that?
My mom.
Did anybody get negative 87? A mistake that's made here sometimes is we do it in the wrong order. Always, always, always start with the first number. So always start this way. That's where we start. All right?
You start at -1 and go down?
Always. Always. Because you went the wrong direction.
Right, but it's supposed to be on the bottom.
This is negative 10. This is 77. All right. Now, I need to erase this because this next one's going to take a ton of room.
It's like, it could be just
I was sweating.
All right. The procedure that we're about to do can be done on a 3x3. Now, I prefer, and most of my students over the years prefer, to do the 3x3s the way we just did it, by recopying the 2 columns and doing the multiplication. But those can be done the same way that we have to do a 4x4 or anything bigger. All right? The process we're going to use is called expansion by minors. And when they say expansion, they are exactly right. This is a big, big, big problem. It's easy, but it's big. And you have to be so careful with your arithmetic, because one little mistake throws everything off. All right, so here's what we do. Take that first row of numbers and write them down, spread them out. So 1, 2, -3, 4. It's called expansion. Spread them out. Now here is the step that we forget. Once you get those numbers written down, you say to yourself in your head, this sign, positive, will stay the same. This sign will change. This one will stay the same, and this one will change. So always when you write down your row, no matter how big it is, so if this is a 5x5, we have 5 numbers written down. Always the first one stays the same, change, same, change. Just keep on going. And then cross off that first row, we're done with it. We're not going to use that row anymore in our work. It's right here, we've got to take care of. Now, you see this 1 right here? That 1 is this one. I've already crossed out the row. Now I'm going to cross out the column that 1 is in. So take out the row and the column for that 1. Well, if I do that, what's left right here? Oh, wowzy. Here we go. That is called a minor. That's a minor determinant. It's a smaller piece of the big determinant. Are we going to have to evaluate that? Oh, yes, we are. And we're going to have to evaluate one for each of these. So this one, we're going to cover up the 2 column. So that'll be 0, 2, 0, -2, -3, 1, and 0, 5, 6. So you take out the column. The row's already crossed out. Take out the column that the number is in. All right, and the same thing here. And okay, see how easy it is to make a mistake? Oh my gosh, don't let me make one.
So scary.
You know what to do now. You're going to evaluate these guys. So I'm going to take the first 2 columns. And I'm going to start evaluating. don't just blindly copy down what I have, because it's probably full of mistakes. So you're doing it and kind of checking with mine, seeing if we match.
Have we done the odd numbers yet?
No, and then anything of those yet. I'm just evaluating the determinants. You probably know what's gonna come next.
Wait, I did 0 minus 1.
Sandra, a mistake.
Wait,
Which
did I
one?
do that wrong?
I may have, which one?
I did 0 minus 24 for the second one and got negative 24. For the,
Oh, did you get this to be negative 24?
yeah.
Okay, so it's 0 minus negative 24. Remember, those numbers get subtracted.
I don't know why. Okay, I messed up the. Okay. I lost the negative. See, I know. That's why I didn't say anything. It's like you're right on that.
I got negative
4 1 0. 0.
Okay, anybody get negative 27 for the first one?
Yes.
24 for the second one?
Yeah.
12 for the third one?
Yes.
And negative 6 for the last one? We're almost done. Except one little multiplication error and the whole thing's blown, so you gotta really, really be careful. Okay, now remember those numbers we copied down at the beginning from the row? They now become multipliers. So you're gonna take 1 times negative 27, that's negative 27. We're gonna take negative 2 times 24, negative 3 times 12, and negative 4 times negative 6. All right, so everybody see what I did? Once I got my determinant evaluated, times by this number out in front. And then add them up. So that's gonna be the answer, so what is that? Negative 87?
So on the last one, we subtracted, but on this one,
Well, because these are actual determinant values, when this is a part of the determinant. I mean, it is, but not part of multiplying the diagonals. This is just the number times the coefficient, and then yes, add it all up. All right, one more thing before I send you out for lunch. I want you to think about this. It's gonna ruin your lunch. I want you to think about this. What if this had been a 5 by 5? Okay, now think about that for a second. So you have 5 numbers written down, but then think of these minor determinants here. Each of those minors would be a 4 by 4 that you would then have to do this to. Can you even imagine that? This is the only way to do that problem. There's no other way to do it. All right, when we come back to lunch, we'll pick up here. Back at 50. Back at 50, people. 50.